Once we are thorough with the Biot law and its application, then the derivation and the basic equation, now we must be able to solve the problems based on Biot law. Of course, we should be thorough with the derivation of Biot law. So this kind of preparation for examination or for deep learning is called, that is, model problem mapping. So we should check all the possibilities, like what are all the different variances, that is variables involved in Biot law. For example, this small magnetic field element is directly proportional to current. It means higher the current, higher will be the magnetic field. Similarly, dB is directly proportional to dl. What do you understand from this? By increasing the length element, you are increasing the magnetic field. Similarly, when the angle is getting wider, that is sine of angle of theta is increasing, it means that is the dB is also increasing. Whereas when the distance, that is the distance between the point and the current element, I mean the length element is, uh, I mean increasing, automatically dB will be decreasing because it is inversely proportional to R squared. Okay. So likewise, probably they may ask some questions based on the ratio. For example, they are passed a 5 ampere current for which the magnetic field obtained was a 5 Tesla, assumingly. Then what could be the value of the magnetic field when the current is doubled? So in this case, you can make use of this kind of ratio equations. For instance, dB2 is proportional to I2, dB1 is proportional to I1. You can divide these two ratio and thereby you can make the equality here. So using these equations, you can instantly solve the problem when it is asked in 1 marks or 2 marks. In objective type questions, they are asking similar questions. Similarly, dB is a proportion to dl, means twice the dl in the magnetic field will also be doubled. And similarly, the theta can be a variant and we can change the or also. So likewise, we should be able to arrive at the ratio forms of these equations also. Then you should be aware of that the cross product. So I cross J gives K. J cross K gives I. K cross I gives J. So likewise, we should know the cross product formula. And based on that, this should be helpful for finding out the direction of the magnetic field appearing here. Now let us consider one problem. It is a straightforward problem. That is a problem here asked is a charge is moving, say dl, that is a delta xi. It indicates that it is moving in the x direction. I cap means unit vector along the x-axis. So that is given as a point as 1 centimeter along the x-axis. It means 0.01 centimeter along x-axis. Then the current passing through this is 10 ampere and the magnetic field on the y-axis is how much? That is the question asked. R is given 0.5 meter. So delta x is also given. So based on that, you can directly substitute using this equation, Biot-Savart's law equation. That is the scalar form dB is equal to mu naught divided by 4 pi into ideal sine theta divided by r squared. So here theta is taken as 90. So sine 90 is equal to 1. And therefore 4 pi into 10 power minus 7. That is the value of mu naught into I 10 ampere dl, the 10 power minus 2. Sine 90 we already know 1. So whole divided by 4 pi into and this r squared, which is nothing but 0.5 squared. So you were able to get the value dB as 4 into 10 power minus 8 Tesla. Don't forget to put the unit of magnetic field. Now the direction is also asked. So in that case, in fact, that is this is also in x-axis and this is in y-axis. So I cross j means it should be in the third dimension, that is along k above the plane of the paper. So in that case, you can put k. So you can simply mention that the magnetic field acts on z direction. So likewise, you should be able to arrive at the model problem mapping for the given, law or the principle, so that it would be very comfortable for you to solve the problems. And you can predict various types of problems based on that, this kind of model problem mapping. Okay. All the best. Thank you.